viewers, welcome to my channel. In this episode, we want to continue with the integration by substitution. So we have the integral of into bracket x plus 1 over x all raised to the power of 2. So we can still convert this fraction to become a linear term, as in integral of x plus x exponent minus 1 squared dx. This is just under indices, the reciprocal, so you have a negative exponent. So now we can decide to expand the bracket and simplify before we integrate, or we use integration by substitution. I will substitute this with a different variable. So we have let u equals to x plus x exponent what? 1. So in the bracket, leaving the exponent. So after finding u, we need to find the du dx. You need to differentiate u with respect to what? X. And if you do that, if you differentiate x, see there's 1 here, it comes out to give you 1. 1 minus 1 is 0, so the whole of this become 1. Then this is also going to be the whole of this coming forward to become minus 1, multiplying the minus 1, we subtract 1 from it. And if you subtract 1 from negative 1 minus 1, that becomes a negative 2. So this is just going to be 1 minus, we don't write a 1, so we have x exponent what? Negative 2. I'm only bringing it to show that the negative 1 come forward to multiply. So now it means we have du dx equals to this. But we need to, since we substitute this with u, the dx must also be a value of what? U. So what do? We find the dx from here. So dx is going to be, so let's rewrite this. Du over dx is now equals to 1 minus x squared, or this over 1. So if you cross multiply, this will multiply this. This will become the coefficient of this, so we can divide by that. That means your dx is going to be du over 1 minus x what? Exponent 2 is negative exponent 2. Now, so it means this is the value for dx, which this can also be written as dx equals to, taking this to be a factor to multiply, it becomes 1 over 1 minus x exponent negative 2 du. We can write that, we can maintain this, we can also have this. So now we are going to substitute back dx and u into the integral, meaning the integral of the whole of this is now what? U. And u is having exponent of 2. Then dx, which is now going to be 1 out of 1 minus x exponent 2 du. So we are aware that this is taken as a constant, multiplying this. So this can come before the other one, or we can also take this as an exponent, as a coefficient, which can also come to multiply the integral. Or we have our integral of 1 out of 1 minus x negative exponent u squared du. Now there is something wrong here, because even if I have so many variables here, the differential du is telling me to integrate only the u function. Even though I'm having an x function, I cannot integrate the x function, because the du tells us to integrate only the u function. So we ignore the x and perform our integration. So this is going to be 1 out of 1 minus x exponent 2. Then this is going to multiply u. If you increase this one, we have 3. We divide by the 3. Then plus what? C. Then we are aware that this can be substituted. with its original term. So that could become 1 over 1 minus x exponent 2 multiplying. This is going to be x minus x exponent 1 or exponent 3 divided by 3 plus what? C. And I think since it's a fraction multiplying a fraction, the numerators can multiply together to give us x minus x exponent 1 raised to the power what? 3 divided by 3 multiplying 1 minus x exponent 2 plus what? C. So that will be the integral of this function. Alright, so the steps are still the same. Substitute, find the differentiation. Then in that differentiation, find your dx. Substitute the u and the dx back into the integral. Perform your integration. Replace the u with the function of x. Then that will be the final answer. Thank you for watching. Like, share, and comment. Bye-bye.